Here we have a square ABCD. Inside of the square we have a segment AE, which is at 60 degrees to the side BC. Also from point E, we draw a segment EF, which is also at 60 degrees to the side BC. And we are asked to find the angle between the side AD and the segment EF. This problem could be solved in multiple ways. One way is to extend the segment EF until it intersects the extension of the side AB at point G. And now if we look at these two triangles, the peach one and the green one, we find they're congruent. They're congruent by two angles in the side. The side is the side BE that they share. The angles are angle B because they're both 90 degrees, and the angle E because they're both 60 degrees. The bottom angle E is 60 degrees because we are told that it's 60 degrees, and the top angle, angle BEG, is 60 degrees because it's a vertical angle with this angle, CEF, which is 60 degrees. And vertical angles are always congruent, as we know. In congruent angles, the respective sides and angles are congruent. So we find that this angle G and angle A are 30 degrees each. And also we find that both of those triangles are 30, 60, 90 degree triangles. In those triangles, the relationship between all the three sides are known. If you're not familiar with that, there is a link below where it's described. If we assume that side AE equals to 1, and we can always do this, in this case, the leg opposite of the angle of 30 degrees has to be half of the hypotenuse, so it has to be 1/2. And the other leg we can quickly find from Pythagorean theorem, and that's going to be square root of 3/2. Since this green triangle is congruent to the peach triangle, the side GB also has to be square root of 3/2, and the hypotenuse GE has to be 1. The next thing we're going to do, we're going to look at triangle ECF. It's a right triangle with an angle of 60 degrees, so the other angle is 30 degrees. This triangle is also 30, 60, 90 degree triangle. And in this triangle, we actually know one of the sides EC. That side will be the side BC minus BE, and that gives us square root of 3 minus 1/2. And that's the leg in this triangle that is opposite of the angle of 30 degrees. That means this leg is half of the hypotenuse. And hypotenuse EF is double that leg, and that is square root of 3 minus 1. Now let's look at the side AG and side GF. They're both square root of 3, which means this great triangle AGF is an isosceles triangle. Angles at the base of an isosceles triangle are congruent. This angle, the third angle, is 30 degrees. It means that both angle A and angle F have to be 75 degrees. But that means that the angle right here, the angle we're interested in, has to be 15 degrees if we to expect these two angles together give us 90 degrees. And this is it.